more factoring. I'm going to try to factor all kinds of different kind of factor problems for you. The only thing I don't have is factor by grouping, but I think we did that pretty well already. But I wanted traditional factoring sort of kind of idea. So all different kind of factoring problems. So the directions are just factor. So we have t squared plus 15t plus 50. Hey, I am going to highlight the other way you could factor. It's called the AC method. I do it as an X. I sort of showed you like 2 problems last time, but if you just are really struggling with factoring, this is the other way you could do it. So
I don't mean to interrupt, but is it just me, or can we not see your whole whiteboard page?
Oh no,
it looks like it's cut off.
Hold on. I moved it, or it got moved. How's that? Is that good?
It's much better. Thank you.
Yeah, sorry. I'm sorry. Sorry. I didn't even realize I even moved. Here, let me make it bigger too. Boom. There we go. Love it. Okay, so the way we did it last time, we would think of 2 numbers that multiply to be 50, but add up to be 15. And I don't know what comes to your mind, but I'm thinking 10 and 5. So t plus 5, t plus 10. It could be t plus 10, t plus 5. And if you FOIL it or double distribute it, you'll find out that that's the answer. But let's say you had trouble with that. So this is called an AC method. I do it as some people do it as a box. I do it as an X. It doesn't really matter. But the AC method says that you're going to multiply the first and last numbers. Now, this really has a 1 in the front because there is no number in the front. It doesn't have a coefficient. So 5 times 1 would be 50. So you put whatever it needs to multiply here. This is the multiply part. And then down here, you put the middle term, which is the add part. And then you, again, the same kind of questions. You ask yourself, okay, 2 numbers that multiply to be 50, but add to be 15. Now you guys have your calculators too. So when these numbers get big, which I wasn't thinking of last time, you have a calculator. So when these numbers get big, take your calculator out and start dividing numbers till you find the right combination. But it would be 10 and 5. Now the AC method says that you have to divide by the first coefficient, which happens to be 1. We will have other numbers there soon, but it's all done exactly the same. And then you have to simplify. You have to simplify. Can that be simplified? No. Okay, now our variable is t. So I put t on the bottom, or whatever variable it is, and then you're going to go backwards like this. And since 10 and 5 are positive, it would just be t plus 10 going backwards, or 1t plus 10, but we don't need the 1. And 1t plus 5, which is the same thing as saying t plus 10, t plus 5. This method comes really in handy if you're really having trouble with factoring when you have a leading coefficient other than 1. But if you are fine in factoring, this is what I want you to do. You're just practicing. If you are not fine in factoring now, you're going to watch and follow me and see which method you like. There's the traditional method, the way I showed you last time, and I'm going to highlight more of the AC method in case you're having trouble. Okay, and feel free to ask any questions too. Okay, number 2. Let's see, I have x squared plus 4x minus 12. And some of you who know how to factor, because if you were in developmental math 2, you learned how to factor. You probably have your factor skills already. If you're just joining us because you tested into this class, then maybe you haven't factored in a while. But all right, so I would do x and x because x times x is x squared. I need 2 numbers that multiply to be 12, but add up to be negative 12, sorry, and add up to be negative 4. Well, the first thing that comes to mind is 6 times 2, right? 6 times 2 is 12. If I add them by putting 1 a negative, I'll get a 4. So I need a positive 4, which means my 6 had to be positive and my 2 had to be negative. So 6 times negative 2 is negative 12, but 6 minus 2 is 4. So it would be x plus 6, x minus 2. One thing you want to keep eye on too when you factor, you want to check these last ones. You want to check the outside and you want to check the inside and just make sure one more time that you're getting that 4, which you are. I'm going to erase that, but that's where you want to check. You want to look outside and inside and check that number. Now, if you're doing the AC method, you would multiply the ones here, right? 1 times -12. They have to multiply to be -12. They have to add up to be 4. What 2 numbers would they be? Well, they'd be 6 and 2. And I'd have to have a positive 6 and a negative 2. I divide by the leading coefficient, which happens to be 1. So I'm just going to put 1 here for a minute. And then I look at my variable. My variable is x. I can't simplify them, but I'm going to add x to the bottom because I'm going to rewrite this in opposite order. This would be x plus 6. This should be x minus 2. And whichever way you did it, you got your answer of x plus 6 and x minus 2. So I want to do one more like these before I add on to something else. X squared minus 22x plus 40. I'm going to start with the AC method first. So this time, okay, so we multiply. We had to multiply to be 40. We had to add up to be negative 22. So 2 numbers that multiply to be positive 40 and will add up to be a negative. So that means that it had to be a negative and a negative, because a negative plus a negative is a negative, and a negative times a negative is a positive. It's the only way to get a negative middle number and a positive last number is negative and negative. So now I can think of it a different way. So I know they're both the same sign. So what numbers would make 22 out of 40? Well, that would be 20 and 2. So negative 20 times negative 2 is positive 40, and negative 20 plus negative 2 is negative 22. Then I go back and I realize my leading coefficient is 1. I'm going to divide by 1, which you really don't have to, but I'm going to because I'm going to add my variable to the bottom, which is x. And then we read these both backwards. So that would be x minus 20 and x minus 2. And then I want to check myself real quick. I'm going to go like, okay, that is negative 2. And that is negative 20. They're both x's. That's negative 22. I like my answer. And of course, you can do it the traditional way. X squared becomes x and x. I have a minus. I have a plus. That's a minus minus. It would be 20 and 2. And I'd have the same answer. And now always be careful of something that could be factored out first. The ones I gave you first had a 1 coefficient in the front. So nothing could be factored out. They didn't have variables, but this one's going to have something we can factor out first, because you never want to do, if you're going to do this method, you want to make sure it's factored first. It has to be factored first. So 7x to the third minus 35x squared minus 42x. So I definitely see everything has an x. I know I can factor out 1x, but look at our coefficients, our numbers, 7, 35, and 42. All right, they're all factors of 7. So I can factor out 7x first. What does it leave me with? I have x squared, because remember, you're just sort of dividing by everything by 7x. You don't have to write this, just thinking this, minus 5x minus 6. And then I really suggest that you bring this down and put your 2 parentheses, because you're going to forget that. And then your answer is totally wrong. So just don't forget what you factor out. It has to be in your final answer. All right, then I'm going to come over here. I'm going to do the AC method. Remember, the 7x is already taken care of. It's gone. So I'm just doing it this part. 1 times negative 6 is negative 6. My adding part is negative 5. I need 2 numbers that multiply to be negative 6, add up to be negative 5. Well, the only way that can be is if it's a negative and positive, because a negative times a positive is a negative, and a negative plus a positive can be a negative, right? So what numbers will multiply to be 6, but I can make -5? That would have to be -6 and +1. Now I go back and look at my leading coefficient. Now remember the 7x is taken care of. So you're looking back at this parentheses. That's still a 1. And then my variable is x. So when I go backwards, wow, that was like a bad x. I can put that right in my parentheses I wrote. This would be x minus 6. And this would be x plus 1. And I might take a second and just check myself. So this would be 1x. This would be -6x. If I add them together, I definitely get -5x. So I like that problem. And again, you could do it traditional way, just knowing that you needed -6 and 1, and you could factor it. Five, -x to the 5th minus 10x to the 4th minus 21x cubed. Again, I see lots of x's, so I know we can take x's out. But I also see here, that's a -1 coefficient, so I can't take any numbers out, but I can take the negative part out, which is like -1. We have to take a negative if it's first. So I know we have to take a negative out. And I know we have x's to take out. So what's the smallest exponent? The third power. So we're going to take -x to the 3rd out. So then we're really sort of dividing by -x to the 3rd for each of them. Okay, so what am I left with? A negative divided by negative is a positive. X to the 5th over x cubed is x squared. Again, a negative divided by negative is a positive. I have a 10. X to the 4th divided by x to the 3rd is x. Again, a negative divided by negative is a positive, 21, and my x cubes I don't need anymore. So that's my new inside function that I have to factor. And again, I highly suggest you write this down and do your 2 parentheses. Now, if it's not factorable, you just go back and erase it, and then your answer would be what we have written already. But I always sort of take this step in case it's factorable. Most of the time, it's going to be factorable. Okay, so
you wrote -3 or -x to the squared instead of -x cubed on the
yeah, I just saw it as you said that. I'm looking down, going, wait, I put it 2. Very good. Okay, now without the AC method, what 2 numbers multiply to be 21 but add up to be 10? Most of the time, if you're not doing the AC method, or even the AC method too, honestly, it's usually the first or second combination that comes to your head. And 21 to me is 7 and 3. And that happens to be 10. So be x plus 7 and x plus 3. All right, questions on them? Because now I'm going to add a leading coefficient and we're going to factor that way. It's something beside 1. We're going to put a coefficient in the front. And again, if this is something you're really good at and you don't need to listen to anything I say, just write the problem down and factor it and wait for me and see if you got it right. You never have enough practicing factoring. That was 5, so I'm on 6. 6. Okay, so now we're going to mix it up a little bit. I'm going to show you why the AC method doesn't always work, but I'm going to save that for a little bit later. Let's do one that sort of kind of works. Okay, so let's do this one. -8 x to the 4th minus 22 x to the 3rd minus 15 x squared. All right, so I definitely see x's. I know I can take an x squared out. I know I can take a negative out. I have to take the negative out first, but can I take anything else out? And I would say no. I see -x squared. So let's figure out what's left. So -x squared, -x squared, -x squared. Okay, negative divided by negative is positive. I have an 8. X to the 4th divided by x squared is x squared. Next one, negative divided by negative is a positive. 22. X to the 3rd divided by x squared is x. Negative divided by negative is a positive. 15, and the x squares go away. Now, these are the harder ones to factor because you have to worry about the 8 and the 15 and the 22, right? So that's why someone developed this, what they call the AC method, which I'm going to do. I'm going to show you. Okay, so what you have to do is you have to multiply these together. And 15 times 8, 15 for 120. So when they get to be bigger numbers, it gets a little harder. And then what's the number that it adds up to? 22. I already sort of know that has to be positive, positive. So I might just write that. Sometimes I do that to remind me it's positive and positive. All right, so we need two numbers that multiply to be 120, but add up to be 22. Now, I don't know about you guys, but I just got a big thunder. So I'm hoping if I go off for some reason, or one of you go off, just hang on, I'll come right back. I'm hoping I don't lose power. I lost power in the last thunderstorm, so hopefully nothing. Okay, so I know 60 times 2, that's not going to work. 40 times 3, that's not going to work. 30 times 4, but 10 and 12. 10 times 12 is 120, and it adds up to be 22. Now we have to go back. Remember to minus x squared. That's done. It just stays out. And I just did totally what I told you to do first. I didn't do. There, boom. All right, now I have to divide everything by the leading coefficient. I have to divide by 8. You have to simplify these. Think of it as a fraction. It's like a fraction. You got to simplify it. So I can divide both of these by 4, which makes 3/2. And I can multiply both of these by 2, which is 5/4. Now it's an x, so I'm going to add my x to the bottom, and I'm going to read them backwards. And notice they were both positive, so I'm going to put that positive right there. So what am I going to do? I have this one, which is 4x plus 5, and I have this one, which is 2x plus 3. It's really easy to look at this and go 5 plus 4 or 5x plus 4. So always remember it backwards, upside down. I always put the arrow to remind me to go that way. Now, just to double check myself a little bit, I'm going to go like this and go, okay, 12x, 10x, I got 22x. I like it. I'm good. And that's my factoring. Now, you could also do that without this method. You can also do the combinations like things that multiply to be 15, things that multiply to be 8, as we did before, and put the combinations together. That's how you like to factor, and you got it down. I 100% really do say that's the best way to factor, but I want to show you the other ways as well, just in case. All right, this is why I don't like the AC method all the time. Granted, it doesn't happen all the time, but here's a problem. Okay, so 4w squared minus 36w plus 81. I hope you would know what to do with this problem without doing the AC method. We'll talk about that in a second. But if I do that AC method, I have to multiply 81 times 4. Now that is 8 times 4 is 24, 324. Let me just check myself, make sure I'm right. 81 times 4, yeah, 324. And I have to get a negative 36 when I'm add them together. Okay, the only way to get that is they're both negative. Oh, negative and negative. A negative times a negative makes a positive, positive 324. A negative plus a negative makes a negative, negative 36. Is the only way. Now, this is, I don't know the answer to this. I got to take my calculator out. I got to find a combination of numbers that when they multiply to be 324, make 36. That's going to be a little hard. That's probably going to take a little bit of time. 324 happens to be a perfect square. Anybody know that? So, and that's just because I sort of kind of remember 324. So the square root of 324 is 18. And 18 is 36. Now, granted, I might have to think about this for a little while, but that's what it is. Okay, so now I have to divide both of them by 4. Now I got to simplify. They're both negative 9/2. negative 9 over 2. It's a W, so I put a W on the bottom, and then I'm going to factor, going backwards, backwards, backwards. 2W minus 9, 2W minus 9, which can also be written as 2W minus 9 squared. But I want to show you the real way I want you to think about it. This is a perfect square. This is a perfect square. When you have the first and the last coefficient, the first and last numbers, perfect squares, I want you to always, always, always try this first. 4, 2 times 2 is 4. That's why it's a perfect square. 2, 2. WW. 9 times 9, 81. 9 times 9. I have a minus and a plus, which is a minus minus. Now, I don't know if it works. Well, I do know it works because we just did it, but pretending I'm doing it for now. I don't know if it works. So now I'm going to check my middle and my outside and insides. I get negative 18W, negative 18W, and it happened to add up to negative 36. So this is a special problem where you have perfect squares. And when you see perfect squares, you should always use the idea of perfect squares first. Most of the time it works when you factor it. So you didn't even have to do all this with this big number. You could just think about perfect squares and try to factor it that way. Next questions? Anything? We're going to do more. Hey. Oh yeah, before I forget, the change in schedule means that our test is next Monday. So I changed all the homeworks to be due on the night before, which is the 17th. And then I also moved the other test back a little bit, and I changed all those due dates for your homework on that too. So you should have, and if you see anything that's not changed, let me know, because I cannot tell you how many times I change it, and it winds up coming back after I come back to it. I don't know why. I must be doing something wrong, but anyway. So all this homework is due the 17th, and then the test is next Monday. We're going to finish up the chapter on Wednesday by doing the last 2 sections. All right, sorry, I'm going to type the game class and I just totally forgot. So let's try this one. 4v squared plus 13v plus 10. Number 1, I can't take v out because 10 doesn't have a v. Number 2, I can't divide by anything. So we're going right to factoring. Four times 10 is 40. And then 13 is in my bottom part of my x. They're both positive, so it has to be positive, positive. So I need 2 numbers that multiply to be 40, but will add up to be 13. And I don't know about you, but again, go to what you think of first. I'm thinking right off the bat, my head went to 8 times 5, right? Is 8 and 5, 13, 8, 9, 10, 11. Yes, it is. Okay, so 8 and 5. 8 times 5 is 40, and 8 plus 5 is 13. Now we have to divide by the leading coefficient, which is 4. Also means we have to simplify if we can. 5 over 4, I can't simplify, but this becomes positive 2 over 1. Because why I need the 1? Because I'm going to add that v. Now v goes on the bottom and the bottom and the denominator, and then we're going to go backwards and backwards. And when I factor this, I'm going to get v plus 2 and 4v plus 5. And again, I might check my outsides inside just to make sure it worked. I didn't do anything wrong. 8v, yep, definitely adds up to be 13. I'm happy with that answer. That's my factoring. We're going to use factoring in the next section after we finish going over a little bit. And you're going to see why we need to use it a lot. All right, let's do 9.
Wait, I got a question.
Yeah, go for it.
So what if you just did the regular method and not the X method?
Absolutely. I prefer you do this way. Actually, did you get it right?
No, ma'am.
So it's like the traditional way, 4v squared plus 13v plus 10. You would be thinking like 10 times 1, 5 times 2, 2 times 2, and 4 times 1. And you got to find that combination that will give you that 13 when you add it together. So, and I'll tell you right what I see right now, right here. If I do 5 and 1 together, that's 5. And if I put the 2 and the 4 together, that's 8. And 8 plus 5 is 13. So you have to be really careful when you factor it. So I need 2 and 4 together, right? The 4 has to be in the front and the 2 has to be in the back somewhere. So if I put 4v here, that means I have to have 2 here, because then when I multiply it, it makes that 8. That means that the 1v or v had to go there and my 5 had to go there. And I would go like this and I go, okay, that's 5. So I have 8v here, I have 5v here, and I got 13. And then I just have to put my adding and I got my answer. That's the way we did last time. Find the multiples, see what pairs up to make 13, and then figure out the answer. But notice the same answer, just written backwards, but it's the same answer. That helpful?
Yes, ma'am. Thank you.
You're welcome. A9. That's what I was doing. I was doing this one. 4n cubed minus 11n squared plus 6n. Well, as soon as I wrote it, I realized we had too many n's. So I know we can take an n out, and I think that's all. 4, 11, 6, that's all I can take out as an n. So n, I'm going to figure out what's left. So divide everything by n. Okay, so we have 4n squared minus 11n plus 6. And then I'm going to go ahead and write this so I don't forget the n. Now let's do this traditional way. Why not? Okay. 6 times 1, 3 and 2. 4 is either 2 and 2 or 4 and 1. We have to find negative 11, but I do know that if I multiply my two numbers and get a positive, and then add them, get a negative, they both have to be a negative. And I know I have an n. So I just got to figure out the combinations that's going to give me 11. So let's look. This one. I want to change the color. This one and this one. So right over here, it's real small. I had 4 and 1 in the front. I have 6 and 1 in the back. How's that going to give me 11? Maybe not. Maybe I did it wrong. Hold on. 4 times 1 is 6. 6 and 4. Nope. Sorry. Wrong one. That doesn't work. Nope. I did circle the wrong one. My eyes went the wrong place. Hold on. It is not that. It is this one. 3 and 2. Because I can do 4 and 3 together, 4 and 2 together get 8, and 1 and 3 together get 3. So 8 and 3, and they're both going to be negatives, right? So negative 11. So it'd be 8. Whoops. Sorry, not 8, 4 and 1. Okay, we got to put 4 and the 2 together. So if I put 4 here, the 2 has to go here. That means my 1 goes with my n for n minus 2. And that also means my 3 goes here for 4n minus 3. And how can I check myself? I can go 4n times negative 2 is negative 8n, negative 3n. I got my negative 11n. Traditional way, you just have to pair up to find that middle number. All right, here's another big one. Hold on. Yeah, let me do one last one, 10. Then I'm gonna hit a couple different problems. Okay, 10. 4n squared plus 31n plus 42. This was a hard one both ways because 42 can be very many things. It can multiply to be many, many things, but let's try, this time we'll try the AC method. But it's also a big number. 4 times 42 is 168 positive. And I have 31 positive. So I know they both have to be positive. All right, 168 and 31. We got to pull a full out of the calculator, I think, because I don't know top of my head what it would be. I could divide by 2, that's enough, and divide by 4. I'm going to think out what I'm thinking. So I have my calculator, 168 divided by 4. 160, I'm going to write down right here what I got. 168 divided by 4. So 168 divided by 4 is 42. That's not going to give you 31. 168 divided by 8. 168 divided by 8 is 21. Okay, well, that's not going to be 30. Let's get close. 29. Okay, let's try 168 divided by 16 is too much. What else can we divide by? Can't divide by 6. 7. 7, it divides evenly. Let's see what it is. 168 divided by 7 is 24. And look, I just found it. 7 and 24 is 31. So one is going to be 7 and one's going to be 24. We have to divide by the leading coefficient, which is 4. So 7 over 4 is fine. Simplify. 24 divided by 4 is 6 over 1. And then I'm going to add my n to the bottom and then go backwards. So I have 4n plus 7, n plus 6. And double check myself. I get 24n, I get 7n, and that makes my 31, and I'm happy. That's factoring. A couple more, and then we're going to hit the next section. I do want to show you some you're going to see for homework, I think. A couple odd ones. 11. Now this one, I would not ever do AC method. You can. I'll show you how to do it. But again, I want you to look at this. Perfect square. And that is also a perfect square. So I'm going to try this. 2x, 2x, 3, and 3. But notice there's no middle term, right? This is that difference of perfect squares. And whenever you have the difference of perfect squares and there's no x term in the middle, you're going to have 1 plus and 1 minus. And that's the answer. If you were going to do this method, same idea, multiply 9 times 4, well, actually negative 9 times 4, negative 36. My middle term, there is none, so you put 0. So what two numbers multiply to be 36, but add up to 0? That would be negative 6 and positive 6, right? And then divide it by our leading coefficient of 4. And when you simplify them, you will get 3 over 2, negative 3 over 2, and you can put your x, and then you'll get the same exact answer. But per difference of perfect squares, they always work that way. Positive. All right, let's stop again. Any questions? Couple more problems, we'll hit the new section, which we have to use factoring the whole section. So that's why I want to make sure we have it down pretty well. Okay, so these are some that are a little different, but you still have to be able to factor them. Last number was at 11, 12. Okay, 12. I know last time I showed you this one way, but I actually want to show you it a little different way. X to the fourth plus 6x minus 27. Sorry, x squared. Now, last time they said use substitution method, you make something like y equal x squared. But honestly, I don't want you to think that way. I want you to think this for this problem. I want you to think, what would you do? This is a think problem. How would you factor this? And factor that. And I'm going to show you how to fix it so it matches our answer. So we're going to factor this. X and X, we factor it. Okay, so if we do the traditional way, 27, two numbers that multiply to be 27, but add up to 6. Well, 9 times 3 is 27, right? So I can do 9 and 3. I need a positive 6, so it has to be a positive 9 and a negative 6. And that would be my factoring. But that's if it was x squared plus 6x minus 27. The only difference between doing it with a square versus a fourth power is that you're adding the square back in. It's exactly the same as that we take x and we make it x squared. And you'll see, we'll multiply it out, I'll show you. X squared times x squared, x to the fourth, x squared times negative 3, negative 3x squared, 9 times x squared, 9x squared, and 9 times negative 3 is negative 27. And when you put together, you're going to get exactly what we started with, x to the fourth plus 6x squared minus 27. So when you see a weird power like a fourth power, you might see a sixth power, do it exactly as a square we've been doing, factoring. And all you have to do is change that exponent to a 2. If it happened to be an x to the sixth power, which I don't think you're going to see this time, but next class you might. If you're factoring x to the 6, let's say same problem, right? X to the 6 plus 6x to the third, that had to be a 3, minus 27. It'd be exactly the same, except you would have x to the third plus 9 and x to the third minus 3 kind of idea. You're going to see fourth powers. I don't think you're going to see 6 yet.
I'm confused.
Okay,
So, okay, where you have the x to the fourth minus 3x squared plus 6x squared minus the 27, how do you get 6x
9.
squared when?
That's a 9.
Oh,
Not a
okay.
6.
Okay,
Yeah,
my bad.
I know it's my handwriting. It's not you. It's me. It's me too. But that's how it got 6x squared.
Okay.
No problem. 13. Okay, so how do you do something like this? It looks so hard, much harder, but it's actually pretty easier. And you're factoring it. So you're going to go each one. You're going to look at the coefficients. You're going to look at the x's. You're going to look at the y's. You're going to look at the z. Don't look at it as one piece. Think of it as all different pieces. So if I go to 4 and 20, what can I factor out? I can factor out a 4. And then I'm going to go to my x's. I have x to the fifth and x to the fourth. You always factor out the smallest exponent. So x to the fourth. Then I go to my y's. Y to the seventh, y to the sixth. 6 is smaller. Y to the 6. Then I go to my z's. Z to the fourth, z to the fifth. That would be z to the fourth. That's what I'm factoring out. Now, what are we left with? You can divide it all, but I know, actually, I'm just going to do that. If we were on a board and you were right in front of me, I could, whoops, that's a 4. Show you in my hands a little better, but I got to write it down because you can't see me better than this. Okay, so 4 cancels. I have 1 x left. I have 1 y, and the z's are gone. Minus, and then we're going to divide this one. 4x to the fourth, y to the 6, z to the fourth. Okay, so I have 5 left. X is gone, y is gone, and I have a z. And that is all you can do. I know you're going to see one like that in your homework, and we really didn't do something like that. But that's all you do. Look at each one, factor out whatever the biggest thing you can factor out from your coefficients, factor out the smallest exponents for all the other ones, and then divide them, and then you wind up having your answer. This one we did like once or twice, but we're gonna do it again. 2x plus 1 squared, where it looks like factoring, but doesn't look like factoring. 2 times 2x minus 1 minus 24. This one, you really do have to use substitution. So you're going to make y, make it anything other than x, because you use x, you can get confused. So I'm going to make y is equal to 2x plus 1. And then what you're going to do, wherever 2x plus 1 is, you're going to put y. So y squared plus 2y minus 24. Now it's a traditional factor problem. So we can factor it with the AC method. We can factor it with our numbers. Let's try just thinking about it. Okay, hold a second. Let's do y. It has to be a plus and a minus, because a positive times a negative is a negative, negative 24, and a positive plus a negative will give you a positive if you put the bigger number at the positive. All right, so think of the things that make 24. 8 and 3, 12 and 2, 6 and 4, 6 and 4. 6 and 4, because if I make 6 positive and the 4 negative, I get positive 2. 6 and 4. That's my factoring. But we're not done, because we have to now substitute back. So what we have to do is wherever y is, we're going to put 2x plus 1 back in. So 2x plus 1, then the plus 6, and then the 2x plus 1 minus 4, and then we just have to simplify it. So we get 2x plus 7, 2x minus 3.
Is that supposed to be a 2x plus 1 in the second set?
Yes. Sorry. Yes, it was. Thank you. Thank you.
Is this 5.7 or is this like getting into the 5.8?
No, this is still, we're not 5.8 yet. We're doing 5.8. Like, this is my last one. We're doing 5.8 next. This is still doing 5.7, just practice factoring. We did problem like this last time. I just want to do one more.
Yeah, oh, I was just wondering because I didn't really feel, I think I maybe had like one like this on the homework. There weren't a
Yeah.
lot of these.
No, there's always like, that's like 1 or 2. I can't remember how many exactly. And you might see it on your tests, but I want to make sure we go over it. So that's really truly the one you get to substitute in order to find the answer. Any other questions? We're all good so far? Okay, that's the end of factoring. I did all I could possibly do over and above, so I'm hoping that works. Let's go to 5.8. Give me 1 second. Okay. Awesome. Five eight. Solving equations by factoring. When you get into the quadratics, which is the squares, you're going to use factoring a lot. You don't have to be squares, but squares. Factoring is used a lot. All right, so let's talk about solving. What does it mean when you solve? Now, this doesn't have to be just for this problem. I mean, for anything. When you solve in math, we talk about algebra. Algebra solving. What does it mean? Lots of times you go through the motions like, oh, the answer is 5, the answer is 4, the answer is -2. What does it mean? What did you just solve? What did you find? What is the answer? What you found is the x-intercept. That's what you found. So even when you do a linear equation, well, let's look for a second. 2x plus y, no, 2x, sorry, plus 4 equals 8. If I was going to solve this, I subtract 4, I get 4 equals 2x, x is equal to 2. So what I really found is if I actually like graph this equation, it would be the x-intercept. It'd be the x-intercept of 2, 0. And it'd be something like this. That's my solution. That's my answer. There's a couple other names I'm going to give for it in a few minutes, but that's what it means by solving. But when you have a quadratic, like x squared plus 2x minus I gotta get the right number. Actually, let me change it. A quadratic looks like a parabola. It's called a parabola, and it looks like this, or it's upside down if it's negative. What you're doing is we're going to factor it. I'll show you what solving means. And okay, so what two numbers multiplied to be -10 of f to be 3? Well, 5 and 2, if I make 5 positive and 2 negative, that would make my factoring. Now, when we solve, we're always equal to 0. So when you solve, you're always equal to 0. I'll write that down in a minute. And then what you do is you take each part and set it equal to 0 and solve. This is my solution. Now, again, it doesn't have to be quadratic, be anything. It's a line. It could be a cube. It could be a 4th power. Every time you're solving, you're finding an x-intercept, which means, I know it's not drawn really great. Maybe I should just redraw it so you get a better idea. Let's draw it. 1, 2, 3, 4, 5. It means this parabola went through 2, 0 and -5, 0. And it's going to look something like this. These are my solutions. So when you solve something, anything, any equation, you're solving where that graph crosses the x-axis. So solving is finding where your graph crosses the x-axis. I want you to know that because that's what that means. It represents that. And that also, as you learn more about math, you're going to learn to use that to help you graph it. You don't want to we actually do a couple problems. So that's the procedure on how to do it. The one thing about is all the names for you're going to see these names used interchangeably. Okay, words used to represent the x-intercept. And you have to get used to these words because you're gonna see them on and off all the time. All right, of course, x-intercept. You can also be called roots. Why roots? Because like a tree, I guess the parabola grows out of the zeros, the x-intercepts. They call it the roots. They also call it the zeros. That's because when we solve, we set it equal to 0, called the zeros. You're going to see those. Oh, you're also going to see a solution. Solution also means x-intercept. They're all the words that say find a solution, find the zeros, find the roots, find the x-intercepts. They all mean the same thing. Finding the x-intercepts. They all mean the same thing. All right, so that's preliminary. So right now we're going to do, I'm going to change the page. Everybody have it? Good. That's our overview. We're going to talk about, we're going to spend most of our time on quadratic equations and solving. And quadratic equations have a degree of 2. Meaning, this is the standard form of quadratic. I'm gonna write that down. Standard form of a quadratic expression is ax squared plus bx plus c. Notice the highest power is 2, and that's why the degree is 2. If it's not a second degree, it's not quadratic. So let's do find the zeros. I'm going to use the words off and on all the time because you're going to see it anyway. Find the zeros, and you're given a problem, which is already factored. X minus 4, x plus 2 equals 0. Notice it's always equal to 0 when you're trying to find the zeros, solution, x-intercept, etc. So what you do is you're thinking of them both as separate. You take the x minus 4, you set it equal to that 0. And then you take the x plus 2 and also set it equal to that 0. Why? I want to know what the 0 is, right? I want to know where it crosses the x-axis for each of them. And then you would add 4 and solve for x. X is equal to 4. And over here, you would subtract 2. X is equal to negative 2. And then you would say, my zeros are x equals negative 2 and 4, or you can put x equals negative 2 and x equals 4. You can put them together as one, do them separate, doesn't matter. How do you know if you're right? You can take those two solutions you found, the 4 and the negative 2, those are the zeros, and you can plug them into your original equation and make sure both sides are equal to 0. Okay, so let's actually start factoring with these and solving. 2. So find the solution. I'm going to use them all. Find a solution. X squared minus 5x is equal to 24. Is it equal to 0? Nope. So we have to put it in standard form, which is that ax squared plus bx plus c has to be equal to 0. So we have to move that 24 over because it has to be equal to 0. X squared minus 5x minus 24 has to be equal to 0. And now here comes our factoring skills. When you have a square, I can tell you how many times I'm going to say this. If you have a square, an X and no X, you're going to factor. So we're going to factor equals 0. That has to stay there. It's going to be equal to 0. X and X. What numbers multiply to be -24 but add up to be -5? You can also do the other method, but that would be 8 and 3, -8 and +3, because -8 times 3 is -24, -8 plus 3 is -5. Now I need to solve. So I set each one equal to 0. And I can solve X is equal to 8. Whoops, not yet. -3 minus 3. X is equal to -3. And these are my solutions. They're my zeros. They're my x-intercepts, et cetera, et cetera. So if I were to graph this, if you saw the graph of this, 3, 1, 2, 3, 4, 5, 6, 7, 8, your parabola would cross at these two spots and be something like that. And this is just a sketch, not really what that's what it looks like. Now, how do you know you are true? It is true. You're going to always plug them in and see if they equal each other. So you can always check your answers with these, especially when you first start. It's a really good idea to check your answers. Okay, let's do another one. Before, any questions? I know it's sort of kind of new. Any questions? Basically, you put it equal to 0, you factor it, and you find a solution. 3x squared minus 29x equals 30. Again, we have to get it equal to 0, so we're going to subtract 30 on both sides. (3x squared minus 29x minus 30 equals 0. And don't forget too, you want to go back and go, can I factor anything out? Is there anything I can do? Answer is no. So we're going to go to factoring. This one, I'll do this method just to show it again. So 3 times -30 is -90. And my middle term is -29. So 29, that's a weird number. Okay, 90, let's see, 330, nope. 10 and 9, nope. 2, nope. I know one's positive and one's negative. That's going to help me too. Okay, so that means I'm going to subtract them. 9 and 30. 10, 30. Oh yeah, well, my mind's not thinking. Hold on. Oh. Anybody have it? Tell me what you have. 10, 20. Is there anything? 20. Anybody find anything? 90 and 29? It looked weird. I think I just have a bad problem. Okay, skip this. I can't find anything that makes 29. Anybody find it? Am I wrong? I think it's a bad problem. Let's do 3 again. I'll change the problem. Sorry about that. Bad problem. Okay, so let's look at 5x squared minus 7x equals -2. 10 to 5. Okay, this one works. Okay, so we're going to add 2x, add 2. 5x squared minus 7x plus 2 is equal to 0. All right, let's try it again. I have 10, I have -7. Okay, this one definitely works. Okay, so it has to be negative and negative. A negative times a negative is a positive 10, and a negative plus a negative is -7. I get 5, and I get 2, which is 7. Now we got to divide by a leading coefficient of 5. And I need to simplify this side, -1/1. And I'm going to put my x on the bottom, and I'm going to write them backwards. Okay, so the first one I get is x minus 1, and the second one I get is 5x minus 2. Now, so let me check real quick. This is -5x. This is -2x, -7x. Okay, got it. Now, that is equal to 0. So I take each part and set them equal to 0. So x minus 1 equals 0. 5x minus 2 equals 0. I'm going to skip the adding part because I think you guys are all right with me going to x equals 1. This one, I am going to move the 2 to the other side as adding, which means I'm going to divide. And I get 2 solutions of 1 and 2/5. If you wanted to check it, you could plug it back in. Now I know 2/5 is going to be, it's doable, but you could use a calculator. You'll see that it works. Four. Now, they might give you a nice little neat little problem. They might give you a problem that has a lot of things going on. For instance, it's still solve for x, 8x plus 9 equals 5. So of course, you're going to distribute and get everything to be in standard form. So 32x squared plus 36x equals 5. Now I'm going to subtract that 5 on both sides. So it has to be equal to 0. 32x squared plus 36x minus 5 equals 0. Okay. This one is helpful because 5, I'm going to do it the traditional way. 5 is only 5 and 1. So I'll make 5, I'm going to make 1. I know of an x, I know of an x, I know one positive and one's negative. I'm just going to make one positive, one negative. All I got to do then is figure out what to do for 32 to get 36. Okay, so I know because this is only 5 and 1, right? So let me put it over here, 5 and 1. My 5s look like s's. They get worse every time. 5 and 1. I had 32. I don't know. The first number that comes to my mind, I think 32 is 8 and 4. I don't know if that's the answer, but let's look. I need to get 36, right? One's positive, one's negative. That's 40. If I get those two together, that's 40. These two together is 4. If I subtract them, I get 36, right? So if I make the 40 a positive and the 4 a negative, I get my 36. Okay, so we have to do 8 and 1 together and the 5 and 4. Well, since I put 5 here, that means I have to put the 4 here because that means they'll get multiplied. And that means the 8 has to go here because 8 and 1 have to be together. Did I get the right sign? We'll see in a second. Okay. Eight and 1. 8 times 5. No, I did it wrong. I did it wrong. Hold on. sorry. 8 and 5 have to be together, 8. 8 and 5 have to be together. 4 and 1 have to be together. I read it backwards. 8 and 5 have to be together and 4 and 1 have to be together. Okay, let's see. This is negative 40x. This is 4x. That's negative 36. Okay, I had the wrong signs. Remember what to do when the signs are wrong? Just change them. Make that a plus and make that a minus, because we did say it had to be negative 40 or positive 40 and had to be negative 4. So that makes positive 40. This makes negative 4, and I have my 36. Okay, so my factoring is 8x minus 1, 4x plus 5, all equal to 0. What I do now, I'm going to set each part equal to 0. Define each of my solutions or each of my x-intercepts. All right, so this side, 8x, I'm gonna add 1, 8x equals 1, divide by 8, x is equal to 1 over 8. One solution. The next one, subtract 5. 4x equals negative 5, divide by 4, x is equal to negative 5 over 4. And that is my second solution. I'm gonna do one more and then we'll take like a 5-minute break and come back. 5. Again, solving 3x to the third minus 12x is equal to 0. So this one's different, isn't it? So we can factor things out, can't we? Yes, we can. And it's only 2 terms. Interesting. Okay, we can divide both of them by 3. And we have x is my smallest exponent of 1. We can take 3x out. All right, so now let's see what we're left with. 3x, 3x. So 3 is gone. X to the third divided by x is x squared. I have minus 12 divided by 3 is 4. X is gone, equals 0. Now, this is when you have to have like your thinking cap sort of kind of thing, like paying attention. This can be factored. Isn't that the difference of perfect squares? Right? So now we can factor one more time. 3x, this becomes x and x. What number multiplies 2 times to be 4? 2 and 2. And when they're different, when they're the difference of perfect squares, which is the only thing you can factor anyway, there's no middle term, so it's plus and minus. So this time we actually had 3 answers, because that 3x is in the front. You have to set that equal to 0 as well. Everything's equal to 0. 3x equals 0. X plus 2 equals 0. X minus 2 equals 0. So we're going to have 3 solutions. Okay, so we're going to divide by 3. So x is equal to 0 is 1. We're going to subtract 2. X is equal to negative 2 is another solution. And if I